we're going to graph a horizontal translation for a trig wave. So a horizontal translation is the k value. The k value in your parent function sine x is technically 1. Okay, so in other words, we got this little formula here, and I'll kind of call it, we'll say the old or original period divided by your k value is equal to the new period. Okay, so the original period is 360.
That is what she asked.
Yeah? Oh, good. So then original period is 360 divided by 1, let's say, when we have our original 1, and it's equal to 360. Checks out. Okay. So let's plot that one to start. Now, we got to know at least one coordinate, and luckily we know the original always starts at the origin. From there, we can kind of deduce the rest. We'll call that 1 and -1, and that's all we're going to work with. We're not going to do any other types of... Did I skip something there? Yeah, I did. Boom, boom, boom. Let's get rid of that. So here's our little sine wave here. Going up and down. It's terrible, but this is our period of 360, and then it happens almost twice. And then you can do the same in the reverse order. So what we're going to do next is we're going to look at the first new period and calculate what it is. And what you could do here, as long as you know your sine waves, for instance, let's say we didn't know the original one. We know the period's 360. As long as I know one coordinate, so say I know the coordinate of 0, 0. If I know the period's 360, I know the coordinate's going to have the same y value at 360. Okay, so it's going to be 360, 0. Okay. And then all I have to think about is really, is it going, where's the next middle? So there's really, think of it like just 5 key points, okay? If my two coordinates are in the equation of the axis, so right through the middle, that means the middle of the function is going to be right there. It's going to be on that same plane. And then we're either going to go up or down, and then the opposite, up or down. Okay. So if it's a positive wave, we're going to go up, and then if it's and then down. And if it was a negative wave, we'd go down and then up. So you can kind of plot your points that way. If, let's say you don't memorize that one. Say it's like cosine, and you do this. This is sometimes a lot easier to do with cosine. If you start at 1, so we start at 90 and 1. We add 360 to that, and that would give us 450 and 1. So we know that the coordinate's going to have the same y value. So if we know we're at a peak, directly between those two, so if you add them together and divide by 2, the average would be 270, we know that would be the trough. The trough would be the absolute lowest point. And then you just kind of fill in the halfways between there. So this is kind of a way, without knowing, memorizing any points, you can kind of pick and choose. So with that being said, if your original period is 360 and the new k value is 3, we divide it by 3, and the new period is 120 degrees. So our new period, let's try to keep the that same concept. We know that our 1 value is going to be at 0. So at 0, okay? And instead of going all the way to 360, this one's only going to occur at 120. 120 would actually occur right in between those. So this is our new period. Everything occurs in between there. We know the a value is positive, okay? So we know that there's going to be a middle point. So whatever's halfway between 120 and 360. Do you guys know what it is?
120 and 360?
Yeah. Oh, sorry, 0 and 120. What's halfway
60?
between? 60. So we know we're going to have another point at 60, okay, because there's a middle. Just like we had done the original, 0, 180, 360. Here we're going 0, 60, 120, because the period occurs within that. So we get a point right in between those. And because it's positive, as long as we know what the a value is, I know I'm going to have one way up here, and then I'm going to have another in between these two way down here.
Oh.
Okay? And then we can kind of just follow that pattern without actually having to calculate what those values are. And you could have done it the opposite way this way. Instead of going all the way 360, we divide it by 120. So we go 120, then halfway between there is 60. And then because we're going the opposite direction, we go down, and then we go up, and then that was kind of off, but we continue the pattern, right? So it's much, much more squeezed. In our other one, original one is 360. We divide by half, which is the same as multiplying by 2. So that gives you 720, I believe. So your new period 720. We'll do this one in red. Okay. This is a little different. You start at the origin, go all the way out to 720. We've got to find what's halfway between 720 and 0. You guys know what it is?
360.
360. So we know we're going to have another point along there at 360. Okay, so that's going to be our middle. And because it's positive, we just go halfway between these two, wherever 1 is. So halfway between 0 and 360 is 180. Okay, because it's positive. And then halfway between 360 and 270, I think, is 540.
Yeah.
The negative one. Okay.
She
So
did talk about this, but she said this in such a more confusing way.
Yeah,
Like she was talking about quarters and stuff.
yeah, and that's what it is. What we're doing is like finding halves and then quarters, but I just keep halving and halving and halving everything. So if we did the same thing the other way. 720, okay, halfway is 360. Then we look halfway between these two, 180, and it's going the opposite way, so we go down. And then halfway between these two is 540, and it would be up, and then so you just kind of think of it as always halves. And my freehanding is terrible, but that's how you can kind of go about graphing those types of things. It is a bit confusing going through this. It might be easier just to plug x values in, but this is a way of just halving everything and kind of finding out where all the coordinates are.